This is TWiT.
There's a lot of programming languages. What makes Rust different?
Oh, what a good question. Well, it really, I'd say that Rust is kind of you've heard of some languages described as cross-paradigm. Rust is really kind of a cross-programmer language because it's not like, you wouldn't think, let me rephrase that. So I know people who come from Rust from C backgrounds, assembly, embedded, and C++ backgrounds, but I also like people who come to Rust from JavaScript or the highest level things imaginable, like the very functional dynamic languages. It's kind of it's sort of almost a way of unifying the two concepts in terms of a systems language that has kind of the sort of functional-ish modern features that you kind of expect from a typical language these days, like closures, sort of map fold operation, although I wouldn't characterize Rust as functional, but it's also incredibly fast, a very modern compiler, sort of state of the art in some ways. We have some dark corners, of course. It's what makes it different. I think what makes it different is that we compete in a part of the language space that has historically been very hard to compete in. And you may notice in the 90s, it was kind of a big thing, so many of these dynamic languages. Python arose in the 90s, Perl, Ruby, and that's because it's really hard to make a language. It's hard to make a language that's really, really fast that can compete with C, at runtime. It's also not fun. It may be hard to make a good language like Perl or Python or Ruby, but it's also really fun to design a really elegant language, right? Where kind of what is the most elegant way of expressing this? What would be the easiest way? And with a systems language like Rust or C++, you have to make a lot of compromises because you care about performance. You care about the machine system and peeling back abstractions and layers and giving people the real control over the hardware that they really require for this domain. And so it's weird because people don't usually if you're just a one-off, an individual author who wants to make a language, which so many programmers are, as so many languages begin Larry Wall just starting with Perl as his own little project, or Rasmus Lerdorf with PHP. You don't usually see a language at this level. And I think thanks to LLVM, which is the Apple but also a community project that makes it possible, because we can finally focus on designing the language itself, making really cool features without needing to go through and optimize individually for every single arch that we want to support.
So how did Rust get started?
Oh, like I said, so most of the languages they start with one programmer kind of just working in their basement trying to scratch their own itch. In this case, it was a man named Graydon Hoare who has worked for the currently. Or let me get back up. So. He worked for a really foundational version control software. It's one of them that predated Git. In fact, it's famous because there's a commit from Linus Torvalds in there where he adds Merkle tree support to it, which we think might have inspired the Merkle tree approach in Git, which is obviously pretty famous by now. But it was one of the earliest distributed version control systems. And so he was working at Mozilla for a while, working on the JavaScript engine there, doing some optimization work, theoretical tracing just-in-time compiler work. And at the same time, he also had to work with C++ because that's what SpiderMonkey is written in. He does some Firefox things at the time. And also working for Mozilla, one of the things that you care about, as any web browser does, is a security profile. In terms of we have users who are really running untrusted JavaScript code in their browsers, and also HTML, CSS. A lot of these things, if they're implemented poorly, they can serve as attack vectors to a user's computer. And that's obviously very bad press. And also, if you don't care about marketing as a moral thing in terms of well, we want to protect our users, it's a pretty good thing too. And so they looked at various ways of well, how can we instrument C++ to make it safer? Is there what's the state of the art out there? What are some of the research languages? And there are some things that you've probably never heard of, like Cyclone, if you want to research more about where the history of Rust came from, just some ideas that currently made their way into Rust through very circuitous paths. And so he worked on this starting in about 2006, just by himself. And then at about 2009 or so, he had the courage to show his employer, hey, I have been working on this thing for a while. And Mozilla at the time was kind of really going all in on very long bets. This was the time of Firefox OS, the whole bootgecko thing. And they were kind of yes, we want to fund you to do this in their R&D department. And so they gave him one engineer, Patrick Walton, and they just set out to build this thing to sort of a minimum viable product state. And that pretty much arrived in about 2011 when they actually rewrote the compiler from OCaml to Rust. And so it became self-hosted at that point, which is kind of a major milestone, kind of like maybe the birth of Rust. But it wasn't actually usable for about 4 more years. But really, it's even though it's from Mozilla and a Mozilla engineer, like it's been like all Mozilla products kind of like very open from the start. And it really by now it is very largely a community project. There's like even among the governing team, less than a third are Mozilla employees.
Well, wait, if it's self-hosted, what did I just compile yesterday on my laptop? Something compiled at MacBoards.
Ooh, I could go on for a long time about self-hosted compilers, which also includes the Go compiler, GCC, and Clang. They're all written in C. Clang's written in C, and compiles using C, compiles using Clang. And the short of it is that you compile a version of the compiler using yesterday's version of the compiler. And that version of the compiler is compiled using the day previous version of the compiler, and on and on and on, kind of down the chain. Tracing back to the original OCaml compiler from 2011, which was abandoned back then. And you can feasibly imagine doing some archaeology to kind of retrace your steps all the way from the past to the future. But it would be pretty painful because we have thousands of intermediate builds by now.
I guess it's sort of like, I'm a big fan of the Smalltalk, and I actually used Smalltalk back in 1982. And that same Smalltalk 80 image basically kept squirting out copies of itself as it went forward and forward and forward. So you can still actually use the. I think the true and false are actually just clones of themselves forever. They actually have like the longest history of anything. A true and false, right?
Rust has a few things like that. As well as Clang. We've seen it before where, for example, in the source code, like the byte for null, it is defined as just being \0, the escape sequence. It's just defined as being the value \0. We're not sure where in the code the last null actually appeared. It might have been in OCaml.